atoms by numbers. We should understand that atomic number is the number of protons. All atoms with the same number of protons are the same element. Okay? That's a key thing. All right? So every single, if you guys have your periodic tables out, which you should, every single atom with 8 protons is oxygen. Every single atom with 9 protons is fluorine. Every single atom with 33 protons is arsenic. That's what defines the element. Atomic mass in the periodic table is the average mass of those elements. We're going to work on calculating that next class. Right, Mr. Costa?
Yep.
And we should ultimately be able to understand what everything in the periodic table means and the information we can get out of it. Okay? So, you guys should have your periodic tables out. Mendeleev, crazy guy, obviously, by the way he looks. We talked about why old pictures look crazy, right? Because they had to stand still for so long so they couldn't smile. And that beard was weighting down his face, so obviously he couldn't smile. And he predicted that several elements would exist without even discovering them. This is Mendeleev's periodic table. He predicted that there was an element between calcium and titanium, even though he had no idea that there was one. Didn't discover it, but he said there would be one. And there actually is one. It's scandium, atomic number 21. Because he knew there was a gap, and he predicted it would have a mass of 44. Has a mass of 45. That's pretty amazing, considering that he had no idea that that element existed. And a few other ones, too. So, that's Mendeleev's periodic table. The modern one was made by Moseley. He, unfortunately, passed away at a very young age, of 28, in World War I. But he was a chemist and a soldier. So this is the modern periodic table. We've talked about most of this already. We have our metals on the left, our non-metals on the right. You have all these different groups. So you guys should have your colored periodic table. I wanted to talk a little bit about the discovery of the elements. Certain elements were known for a long time. We don't actually know when they were discovered. Carbon, sulfur, copper, tin, lead, gold, silver, mercury, and iron. Those are ancient elements that humans have known about for a long time. From the mid-1700s to the mid-1800s, we discovered a lot of elements. Now, so you guys have your periodic tables out. Notice which group is missing. Which group is notably gone from this periodic table from the mid-1800s? The bottom, there's a couple. But look next to fluorine, chlorine, bromine, and iodine. What's next to there in the periodic table?
Noble gases.
The noble gases. Thank you, Colton. Why don't you think we knew about the noble gases? Well, number one, they're gases, so they're hard to find, hard to isolate. But how do you think we discovered a lot of these elements? Think about chemistry. What do you guys think? What do chemicals do with each other? They react. A lot of them. That's how a lot of the elements were discovered, by their reactions. What do you think the noble gases do?
Yeah.
Nope. What do you think, Lindsay? They react less. In fact, they barely react at all. It was a good guess, Lucas. That's a good guess. But they barely react at all. And a lot of times you'll hear things like sealed under argon atmosphere. Where do we hear that? What's that? On the YouTube video, on the Brainiacs, on the thing, they seal the the alkali metals under the argon atmosphere so they don't react. Yes, Griffin. Uranium's a metal, and actually, they used to use uranium in paint, an orange-colored paint. Most uranium is not so bad. It's a very small percentage, which is bad. And we'll talk about what's different about them a little bit today and more tomorrow, next week. Notice the first noble gas wasn't discovered until the mid to late 1800s. Helium wasn't even discovered on Earth. Helium wasn't discovered on Earth. Where was it discovered?
Mars, right?
Space, not Mars, another giant object in the middle of the solar system. The sun. They discovered it by the light it emitted. So a lot of scientists look at a lot of things. Nelson, can you keep your head up, please? So they actually took a look at the light from the sun, and they found a new light spectra. And that was how they discovered helium. Now, Helios is the god of the sun. That's why they got the name helium.
Makes sense.
Yep. And it wasn't until much later, until the late 1800s, early 1900s, when we had most of the elements discovered. And interestingly enough, of the main group, technetium is actually not an element that's naturally found in the here. So Tc, interesting thing. It's the lightest non-element that's not natural. And then we made some elements after that. And we'll talk about how we can combine nuclei to make new elements, and that's nuclear chemistry. We're going to talk a little bit about that. Properties. Metals, they're malleable. They have shine. They conduct electricity and heat. Non-metals, their gases are brittle. Metalloids have properties of both. That's why we use those in computers heavily. And we can manipulate that. One of the reasons for the advancement in technology that's been so rapid is because of the advancements in chemistry and metalloids. So those are extremely important in technology. As we go on to what next technology. Technology is progressing rapidly. Metals, non-metals, metalloids. So that's the metalloid slide. You're more metallic as you get down to the left. Okay? The less metallic you are, the higher up to the right. Think about that. Which one's helium? Probably the least metallic thing in the world. Helium's a gas. Very non-metallic. Noble gases, we'll talk about this. We just talked about this. They don't really react. We'll talk about why later. Really, the reason why is because they're stable. They're already stable. And that's why they call them nobles, because they don't like to interact with all the other elements. Like the nobles of history. They don't like to react with the common folk. Couple information, you guys copy this down, but what we can get from the periodic table. We can get the symbol, which is that, the letters. It's always one capital letter, or one capital and a lowercase. Okay? So it's CL, not CI. The element name is not always on every periodic table. It's on ours. But if you guys are ever taking a class in the future, which hopefully a lot of you guys will, you have to know that the name isn't on every periodic table, so it's important to know the symbols and what they mean. It's like Cl is chlorine. Also, the atomic mass, which is the average mass of the element. It's the decimal number. That's the key. Always the decimal, not the whole number. Periodic tables are different, so sometimes you'll have the numbers switch where they are. But the way you can remember the mass is it's an average, which is okay to be an average. It's like, I'll talk more about that tomorrow. The atomic number, always the whole number. So think about it. You're counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are your whole numbers. Those are your atomic numbers, which is the number of protons. This is the NTK information that we had before. We already have that down. Okay? Parts of the atom. Protons and neutrons are in the nucleus. Electrons are in the orbitals. Also, I find it's perfectly acceptable to call it the electron cloud. Mr. Costa? Okay. Mass, you need to know this. If you know this information, you can probably get 10% of the questions in the mid-year and final right. Okay? 10%. If you guys know this information, have this down. Okay? And know how to use it. So the mass number if you know this, and I talked about this, mass number is the protons plus the neutrons. So go back, look at these things, the slides right here. Which particles have mass? Protons and neutrons. I talked about it before. So that's what has to relate to mass, protons and neutrons. Charge. This is something new. You don't have to copy this down right now. But charge cancels out. That was one of the questions in the assignment we talked about today. So elements always have a charge of 0, meaning that their protons is equal to their electrons. We're going to talk about ions later. But charge is defined as the difference. Charge of protons plus 1, charge of an electron is -1. So do neutrons affect the charge? What do you think? What do you think, Deborah? Do neutrons affect the charge? No, why not? What's that? Speak up. Yeah, because they're balanced out already. They have nothing to do with charge. They're electronically neutral. Okay? That's it.